Today we're going to talk about the rational root theorem. And the rational root theorem is used to help us solve polynomial equations, especially when we don't have a calculator to help us. So here's a polynomial, x to the fourth minus 4x third minus 2x squared plus 26 minus 8. We can also write it in function form like this. So the rational root theorem tells us that you're going to take all the factors of the last term, so all the factors of negative 8, and you're going to call that p. So it could be positive 1 and positive 8, or it could be, it could be positive 1 and negative 8, or it could be negative 1 and positive 8. It could be positive 2 and negative 4, or negative 2 and positive 4. So any combination of these numbers, these 8 numbers really, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, would get us to that negative 8. These are all factors of negative 8. And then it says, all right, well, let's take a look at all the factors of the first term. Well, you don't see anything there, so you know that there's a 1, and you're going to call that q. So 1 times 1 would give me a positive 1, but negative 1 times negative 1 would also give me a positive 1. So that would be plus or minus 1. So you're going to notice always the factors will always be plus or minus. And then the rational root theorem tells us to take all your factors of p and divide it by all the factors of q. So you're going to take plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 4 over 1, plus or minus 8 over 1. And what that tells you is that one of these 8 numbers will be a factor of the original polynomial. So it gives you a list of all the possible factors. Well, in order to find out of these possible factors which of them, if any, are actual factors, what you're going to have to do is use synthetic division. So this is kind of a long method. Certainly your calculator would do this much quicker, but if you don't have the use of your calculator, this would be the only way that you could determine which one of these 8 numbers is a root. So let's just systematically go through them. I'm going to start with positive 1. I'll bring down the 1, I'll multiply, I'll add, I'll multiply, I add, I'll multiply, I'll add, I'll multiply, I add. I don't really care what this last number is. If it's anything except a 0, then I know that 1 is not a root. I'll cross that one off my list and I'll continue on. I'm going to go to 2. I'll bring down the 1, I'll multiply. I will add, I will multiply, I will add, I will multiply, I will add, I will multiply, I will add. Oh, so I immediately now know that 2 is a root, or another way to say that is x minus 2 is a factor. So now I know one of the factors of this 4th degree polynomial. So far I have this. So let's continue on. I need to get this second parentheses down to at least a quadratic so that I could solve it. Right now it's a 3rd degree, so I need to continue. So I'm going to go to the next one and try 4. Bring down the 1. I'm going to multiply, I'm going to add, I'm going to multiply, I'm going to add, I'm going to multiply, I'm going to add. 4 is not a factor. All right, I'm going to go to negative 2 now, just because I know kind of where we're going and I want to shorten this. But if you were to go through each one of these systematically, you would go to positive 8, then you'd go to negative 1 and negative 2 and so forth. I'm going to bring down the 1, I'm going to multiply, I'm going to add, I'm going to multiply, I'm going to add, I'm going to multiply, I'm going to add. And now I know that negative 2 is a root, which means that x plus 2 is a factor. So now I've got this factored down to x minus 2, x plus 2, and x squared minus 4x plus 2. Well, now I've at least got it down to something which is a quadratic, and I can always use my quadratic formula to continue solving this. So I'm going to use my quadratic formula, minus b plus or minus b squared minus 4ac all over 2a. Simplify this, I'll get x is 2 plus or minus the square root of 2. So without using my calculator, I was able to find the factors of this, and I was also able to solve all of this. So I have 1, 2, 3, 4 answers. It is a fourth degree equation, so I am done. So the rational root theorem is really only able to assist you in finding the possible roots, and then you need to use synthetic division to find out of those possible roots which is the real root. If you have any questions, let me know.